Hey guys, very quick on the basics of C. We have, this is our week 2 of Computer Technology 2. We covered variables, input, output, conditional statements, iteration, and arrays, and some Linux command line commands. Okay, so let's start with our first program. Very easy. So we all we need is our standard I/O library. You have to include libraries if you want to use their functionality. So if you want to use, for example, printf, printf is in this library here. If you don't if you don't include your library standard IO, stdio.h, printf will be unavailable. Okay, so below we have our primitive data types. So there are different data types and different you can create structures as well, so you'll have more of those little types in here, but the primitive data types are integer, float, and character. These are the most primitive and the closest kind of to the machine code data types. All they are some binary number that is translated by the computer into something that humans can understand, and so that's all it is. And you have integers, and in this case I just declared it. So what the computer does is it finds some space in stack memory, and it just says, okay, I'm gonna put some integer there. It's gonna be size of integer, so I think it's 4 kilobytes, or sorry, 4 bytes. Kilobytes, Jesus. 4 bytes, and that's it. It doesn't give it any value, and it's a local variable, so only main will see it. If we leave the main function, that perishes, that becomes available for new information in that stack memory. The same for floating here. Floating point variable is the name for my variable, and I initialize it with 10.5. Okay, so it found the memory in stack, it allocated that memory for my new variable, and then it put 10.5 in there. Okay, and the same for character. It found some space in memory in stack, and it assigned it with a. Okay, and remember that pointer, by the way, is also a variable. So but it stores an address of something else. Okay, and that's all the magic about the pointers. But we will focus on pointers later. Basic output. So we have printf, and we also have this puts and something something. I think it's here. Yeah. So we have printf, you have putchar, and you have puts and fputs. So just memorize this, and but the basic, the most common use is printf. So we are printing out our variables now. The default, by default, I mean whatever I put in code, something that is inside of the code, and the user doesn't have an access to it. The user doesn't change it. So we print it out. I use \n for new line. We use \t for tab for nice formatting, and we use %sign for putting a variable inside of the printed message. So in here, I'm using a digit. That's why I put D. You can also use I as it's an integer. And then after closing the quotation marks, after you add a comma, and you list whatever variables you want to put in your printf. Okay, if you had more of those, we just add more after comma, a new variable here. Okay, so the amount of %signs have to match the amount of variables on the right side. Okay, T, that's for floats, that's for characters. We don't go to strings yet, so I'm gonna just, it's not here yet. Here's how you escape the functionality of a sign. So let's say if I didn't put this in here, all the printf would read would be I wanna use, and that's it. It wouldn't go as far as here because I would close it. But with the use of \, I can print it actually. And oh, sorry, Control Z. and you'll see it how. But basically, I'll add that into my code, and you want into my print, and you won't see this full symbol. You will see only the quotation mark. Okay, basic input. It's nice to give a good prompt to the user. So in here, I'm adding change integer variable to. So this is the message to the user, and then the user can add in some integer. And give me 1 second. Somebody's calling me there. Pause. Sorry, guys. Okay, so we're talking about input. So here is your prompt. So you're saying what we are gonna use that input for, and then you use scanf and the data type you want the user to use. The problem is if they use, for example, character here or a float or something, it's gonna crash. So it's good to have some sort of a function or some sort of a loop that checks the input first, and if it's correct, then puts it in. Otherwise, ask the user, could you put the it's invalid input, please put an integer in this case. Okay, so you put in the data type, and then you say where do you want to put it, not in what, in which integer, in which variable. You say where, so you put in an address where you want to put that integer. Okay, then we go to float. In here I created a new float that I'm gonna use for adding. So please add in here. There's a prompt. Add to floating point variable. So we're gonna add some number, and then we're gonna just add that. So in here you can see plus equals sign operator, which means we're gonna add to the value that is already inside of a floating point variable the input from the user. Okay, and here we have character, and note that you need to use a space. You need to leave a space before. In here you didn't have to do it. In here, if you don't leave that, it's gonna do some crazy stuff, and I don't know why, but that's the way it is. You can check it. In here I left the comment, and delete that, save it, compile, and see what happens if you don't have that space. It's strange, but it works that way. And here we just print whatever we changed. Okay. Let's go to conditional statements. So we have if else, we have this little thingy here. This is also a conditional statement. It's of some sort, and we have a switch statement here. So if else is basically you ask something in here, and if it's true, it goes to this line, and if it's false, it goes to that line. The same in here. And in here, I change it slightly. It doesn't matter when it comes to the conditional statement, but you can do it in a more efficient way. So first, you have a statement that you want to print anyway, and then there's the different output is here and here. So in here, you can see this is the full string and full string that shares the same part. In here, I use that shared part above, and then I run the conditional statement. It doesn't matter. It's just me playing around. Anyway, so in here we have some statements. So if the floating point variable is greater than 10, then print greater than 10. Else, so if it's false, if it's lesser than 10, print lesser or equal to 10. And that's it. In here we have this funny one-liner, and basically what we have in here, that whole thing can be encapsulated in here. So basically what it does is it checks if that's true. Yeah, character variable, is it equal to A? If yes, print A. If not, print not A. Okay, so basically it's either we print something, yeah, so this function here will return something to print. It either returns this, or if the statement is false, then it returns this. Okay, and in here we have a switch statement, switch function, I suppose. So basically you put that in here. So you want to compare something to something. So you say, okay, if this, whatever is in here, is equal to this, then do that and break out. If it equals to b, then print this and break out. So not print, but do this, and in this case it's print. If character variable equals to c, then do this, which is print c. And default means none of the above worked, so print this. Okay, do this, and the end of the switch statement. So basically, it doesn't have to be just a variable. You can say, for example, character variable equals a, and then have a case for true and a case for false. Yeah, for example. So basically, this, whatever is inside, and we check if it's a, if it's b, if it's c, if it's true, if it's one, whatever. You can check it for all of them. Not sure if you can compare a char to a floating point or Boolean, but basically you just compare whatever is inside with whatever is next to the case. Okay, so you can see how can be used, how this switch can be used if you have like multiple options. Then you want to use switch. Because otherwise, sorry, I will come back to this. Otherwise, you would go into if, else, if, and you would create a lot of like if else when you can replace it with something much simpler. Okay, iteration. We have for, while, and do while loops. So 3 different loops: for, while, and do while. For is handy when you know how many times you want to do something. So this is how you do it. You initialize some counter, some sort of an index to 0, and usually you'll see something like int I, assign 0, then I, as long as it's smaller than 10, as long as it's lesser than 10, and just every time you finish the loop, just add 1 to I. Okay, that's what that means. Okay, and what we do in this piece of code in here, we just print a number, which is I. So we go from 0 to not 10. It doesn't go as far as 10, so we go from 0 to 9, through 9, through 9, and in here, yeah. So, and it's going to print it out in one line, and then I just want to make a line break. In here we have nested for loops, so you can have a for loop in for loop. I'm gonna save it now. You can have a for loop in for loop, but just make sure you see how I used I in here and I use I again, and you might think like, oh, is it gonna work if it's I again? And it will, because it's outside. This is a local variable I that is used only inside of this loop. When you finish that loop in here, and you're here, you can reuse I, no problem, and you can use it in here in a new for loop, and it's going to be again a local variable for this loop inside. And then if you create a nested loop inside of that loop, then if you put that I in here, that would make a problem. That would create some sort of a forever, not forever loop even. So that would be a mistake. Don't do it. It would scramble. Basically, you would be using the same variable, and after you change it in your nested loop, it goes back changed back to your loop, and it's not good. So basically, when you create a nested loop, stick to I, J, K, and so on. So just don't use the same variable. And in here, it's, for example, why would you use a nested loop if you want to, for example, create a print out a matrix? Yeah, so whenever you're working with matrices, you want to use nested loops. In this case, this piece of code it will print out a matrix that displays the row and column index of every single cell. Okay, we go to while loop here. While loop is handy when you have something like a statement that is supposed to break the while loop. In here, this is not very good example of it, as you can do this with for loop. I would go for for loop, but I'm just showing that you can do exactly same thing with while loop, with the difference that you have to initialize your counter first instead of just initializing that in one line. then you say you put that statement in here, and that statement is equivalent to this statement here. Yeah, it's still in one line, and then you have to add this line, which does this job in here of j plus plus. Here's the counter plus plus. So it's exactly the same as for loop, but it's in different form. And basically, the feature of while loop is that you create a statement that if it's false, then it stops. As long as this one here is true, it goes it creates the loop. It goes back and back and back. And so you can imagine you can use it for your program, your main program, and where, for example, here there is a variable that stands for exit, and as long as exit is false, or maybe not false, but like 0, so it's we don't want to exit, just do whatever menu, uh, whatever options are in menu, and then if you hit exit or whatever is the, how it depends how it's designed, but if we change that exit to 1, then while loop goes, okay, I'm finished, and goes and exits from the program. So that would be the use of your while. And do while is very, very similar, but with the difference that it doesn't check the statement before the inside of that loop. It does the inside first, the do while, and then it checks um, for the answer. It checks for the statement. So, for example, you want to ask the user, "Hey, give me a number," and so you want to at least see it once, that prompt in here. "Hey, give me a number," and if it's 10, I'm gonna exit the loop. If not, I'm gonna stay. If we put that in here, 10, that would still run. Okay, at least once, and then we don't put anything. We put 10 again, and it goes to the next step. Um, Even though the while loop kind of says if it's not 10, exit, but exit after showing this first. Okay, well, I'll change that to 0 now. Save. Anyway, arrays, that would be the last bit, I think. Yeah. So if you want to declare an array, basically an array is a pointer to the first item of that array. There is a piece of memory in your computer, and if you say, for example, this int array1 square brackets 10, uh, you're saying by that you're saying, hey computer, find a piece of memory, a block of memory that will be able to contain 10 integers inside of it, back to back to back to back, next to each other. Okay, look in your memory and put that in. And because it's stack, it's probably there is no problem as long as there is such memory. So that's declaring. Then you can declare uninitialize. So you say, hey computer, give me a piece of memory that will store 5 characters next to each other. And then not only give me that space, but also put m into 0th index, a into first index, r into second, e and k for the third and fourth index. Yeah. Remember, if you have 5 elements, you have the last index will be fourth because we start with 0, not 1. Declaring and filling by the user. So in here we say, hey computer, give me a memory block that will store 5 integers next to each other. And then you ask the user to fill them out. And here's how you do it. You go one by one, you start with 0, and you use that index, that I, use that to fill this. So you say, hey, add this input, scanf, the user put something in there, put that into the memory of the ith element of array tree, okay? And so on. So it's going to do it 5 times, as you can see here. It goes from 0 to 4, so 5 times. And we're going to fill out this array. Okay, and then we are going to print that out. So that's not a huge deal, blah, blah, blah. And then let's do something tricky in here. And we are gonna print those 2 arrays, one of characters and one of integers. but I'm gonna print out those integers, those characters as integers, and those integers as characters, and you'll see what's gonna happen. So I suppose we can finish here, and I'm gonna do the testing of my code on the next in the next video. Thanks for watching.